Hello, my name is Daniel Nenny, and I'm the founder of SemiWiki.com, the open forum for semiconductor professionals. Since going online in 2011, SemiWiki.com has experienced more than 3 million users. If you're not a member of the SemiWiki.com community, please register as my guest. I hope to see you there. Today's webinar is entitled GPU-Powered SPICE, Way Forward for Analog Simulation in partnership with Empyrean Software. Empyrean Software provides electronic design automation software, design IP, and design services, including analog and mixed signal IC design solutions, SoC design optimization solutions, and flat panel design solutions and customized consulting services. The presentation will be done by Chen Zhao. Chen is an application engineering manager at Empyrean Software. He's responsible for application engineering and customer support since he joined Empyrean in 2014. Chen has extensive experience in full customized design and SPICE simulation, and he has an MS degree in electrical engineering and computer engineering from Johns Hopkins University. It's always my preference that applications people participate in webinars since they work directly with real customer design challenges on a daily basis. So please consider this when asking questions during the Q&A. All right, started with the presentation, followed by the question and answer session.
Okay, thank you, Daniel. I'll start my presentation.
Hello, everyone. Welcome to today's webinar of GPU Power SPICE, the way forward for analog simulation. My name is Chen Zhao. I'm the application engineer manager of Empyrean Software. Empyrean Software is an EDA and service provider. Its global headquarters is located in Beijing, China, and I'm from the operations center, which is located in San Jose, California, US. Empyrean Software was founded in 2009, and right now we have more than 300 employees worldwide. So we are all in the semiconductor industry. We know there is a very famous Moore's law over there, but unfortunately, the SPICE simulation doesn't follow this Moore's law. You never saw the SPICE simulation time reduced by half every 2 years. Instead, simulation, especially SPICE simulation, is getting more critical in current designs. Due to many reasons, like the design itself is getting more complicated, and also the introduction of FinFET processes, making the model and more complicated, and introduce a lot of parasitic RCs, making the verification on FinFET process much harder than used to be. Also, IP and also cost of failure are also the critical reasons that making simulation is very important. And the designer also want a high precision SPICE simulator with greater speed and capacity to overcome those key issues. So, in order to solve all those challenges in SPICE simulations, Empyrean Software came up with a tool called ALPS, which is Accurate Large Capacity Parallel SPICE. It is a true SPICE with full SPICE accuracy, and with the help of smart matrix solver technology, which are going to be introduced in next slides, you can achieve 3 to 5 times faster speed than other competitors' SPICE. And it has capacity of more than 100 million of elements, and its accuracy has been silicon proven on 7-nanometer designs. And it was recently voted as best of 2018 DAC in the SPICE simulation categories by one of the media, and you can see the actual user quotes on the right-hand side. So why ALPS can achieve 3 to 5 times faster than other SPICE simulators? You have to understand how SPICE simulator works. So inside one SPICE simulator's jobs, there are 2 parts that it is most time consuming. One is called device evaluation, the other is matrix solving. And for example, in a typical post-layout simulations, the total time of device evaluation and matrix solving can make up more than 90% of total times. And you can imagine if we can greatly reduce this part of time, the total simulation time will be reduced. So we came up with this technology called smart matrix solver. It's combined of multiple approaches to improve the performance of device evaluation and matrix solving part. And since we can greatly reduce the time of matrix solving and device evaluation, then the total time of simulation will be reduced. So with 3 to 5 times faster than others parallel SPICE, Empyrean software still want to move forward. We believe ALPS can be better. Instead of continue working on algorithm, we started looking at other prospects that may help to increase the simulation times. So we're using GPU for hardware acceleration. The reason is first, GPU is a commodity hardware, and they are very stable provider of GPU in the market for past of decades, and you can buy it for a reasonable price, unlike a FPGA or a ASIC. And also GPU itself has a massively parallel architecture, which is one of the key part for hardware acceleration. And the most important thing is there are already many existed scientific applications that was using GPU for hardware acceleration, like AI and machine learning data training or video audio processing or conversion. And with the help of GPU and combined with our already established very fast true SPICE simulator ALPS, we came up with a tool called ALPS-GT. What it can do is with the help of GPU, we can now accelerate the SPICE simulation by more than 10x. So ALPS-GT is the first commercial GPU powered SPICE. The reason we call it the first commercial is we already have several customers paid for it and it has been verified by tape out on 7 nanometers. So what ALPS-GT does is it can accelerate your SPICE simulation by more than 10x, and the capacity is the same as ALPS, which is more than 100 million of elements. And the accuracy has been proven by our customers on 7 nanometer designs with silicons. So with the benefit of more than 10x time speed up, a lot of things gonna be changed. First thing is ALPS-GT can greatly boost your productivities. You can imagine the simulation time can be reduced from days to hours or from weeks to days, and that will shorten your design cycles, which will result to a faster time to tape out or even faster time to market, which is very critical for the company to profit. Another thing is ALPS-GT can do is it can greatly improve silicon success. So because you can running the simulation in much faster time, you can cover more PVD corners before tape out, which can give the designer more confident. And also with 10x time speed up, you can enable some new type of simulation that was previously impossible. So feature-wise, ALPS-GT is pretty standard as other SPICE simulator with supporting the most used models like BSIMs and PSP and HiSim, like some high voltage models. And Verilog is also supported, and we're supporting the generally most frequently used analysis like OP, DC, AC, and transient, as well as corner and Monte Carlo analysis. We also have the capability of mixed signal simulations, and also ALPS-GT is compatible to both Spectre and HSPICE syntax. So you may ask, why ALPS-GT is so fast than other SPICE simulator or even than ourselves? Well, the first thing is, of course, with the hardware of GPU, especially in the recent years, we can get really decent or high performance GPU, general purpose GPU that provides computation powers we need. So here is an example of comparison between the best of CPU provided by Intel versus the GPU provided that we are using for ALPS-GT, which is NVIDIA Tesla V100. So for SPICE simulation, the performance is decided by the cards or the hardware's double position floating point performance, which is also called FP64. So for one Xeon A1A0 CPU, it can provide totally 2 teraflops of FP64 performance, while in a single Tesla V100 GPU card, it can provide 7 teraflops of FP64 performance. The performance difference is caused by the number of cores available in the CPU and the GPU. So in the CPU, it has only 28 physical cores, while in the GPU, it has more than 5,000 FP64 cores. That is why the GPU has much more FP64 performance than the CPU. And right now we have the hardware. The next problem is we need to have the algorithm to massively parallelize your SPICE job, because there are so many cores in the GPU, and in order to take the benefit of hardware acceleration, you have to have an algorithm to massively parallelize jobs to take the benefit of GPUs. So with that, you can achieve 2 to 3 times speed up comparing to current CPU solutions. But the problem is 2 to 3 times speed up is not enough. People typically require more than 5 times speed up in order to adopt the GPU-based flow, because it involves an IT infrastructure change. So one of the reasons we did not get a good enough speed up is that we're using NVIDIA CUDA matrix solver, which is very slow, and that is why we can only achieve 2 to 3 times speed up. And also, that is also why another reason that you didn't see any major EDA vendors even announce GPU-based SPICE in the past decades. So in order to achieve further speed up on SPICE simulations on GPU, you need an algorithm that can solve metric faster on GPU. So that is why we have another key technology called ALPS-GT, which is a GPU-optimized smart matrix solver. And what it can do is providing 5 times faster speed than NVIDIA's CUDA solver. And with that help of ALPS-GT, we can finally achieve more than 10 times speed up than current solutions. So here I'm going to show you some benchmark data between ALPS-GT. So those are cases that actually from our customers, and they have a variety of different kind of SPICE simulators from the market, and they pick the best performing, best parallel SPICE with 16 cores to compare with ALPS-GT. The first case we have is a RX DCO in 7nm designs. It has more than 170,000 of transistors, 8 million resistors, and 10 million capacitors. Previously, it takes 37 hours to running with 16-core parallel SPICE from another vendor, and now with ALPS-GT, the job can finish within 3 hours, which is 12 times speed up. Another case is a PLL that was measuring the random jitter, also in 7nm. You can see the simulation time is reduced from 140 hours down to 22 hours. This is a 6 times reduction on the simulation times. So is this 30 VCO cases is also in 7nm. The simulation time reduced from 94 hours down to 9 hours. That was almost 10 times speed up in this case. Also for this high-speed ADC, the simulation time was reduced from more than 143 hours down to 16 hours. That gives you a 8.8 times speed up. And also here is a CMOS image sensor array, which is 300 by 300. The simulation time previously took more than 94 hours, and with the help of ALPS-GT, it would only take 4.5 hours. That gives you a more than 21 times speed up in this case. Those are the typical simulation jobs we see every day, and they're measuring by hours. But here I have a few other cases that was the toughest and the critical simulation jobs, because their simulation time is measuring by days. Firstly, we have a 30 TX top extracted circuit. It has close 500,000 transistors and more than 20 million of RCs. Previously, it takes more than 115 days for other SPICE simulation to running with 16 cores. And of course, the designer didn't actually running that long. They run probably around 3 weeks and then gave up, and the estimated total simulation time will be around 115 days. And then when they switch to ALPS-GT on this case, it only takes 5 days to finish this job. that was more than 23 times speed up for these SPI simulation jobs with the help of GT. Another case is also a top-extracted high-speed DAC, and still it has close to 1 million of transistors and more than 100 million of RCs in total. The simulation time was reduced from more than 100 days down to 6 days. That was more than 3 months down to less than 1 week, a 17 times speed up in this case. So because those are the toughest and most critical simulations, if that can be reduced, then your whole design cycle can be greatly reduced. And those are the new type of simulation that was previously impossible, and right now they can be finished within a reasonable times. So ALPS-GT is our GPU-based SPI simulation. It can provide more than 10x speed up than your current solutions, and its accuracy has been verified on 7nm designs. It can greatly boost your productivity because it can greatly reduce your simulation times, and also it can improve your silicon success because it can allow you to run much more simulation than before, or even run new type of design simulation that was previously impossible. Thank you for your patience. Do you have any questions about ALPS-GT?
Okay. Now it's time for the question and answer session. If you have a question, just hit the question tab and type it in the box. So we have some questions already. The first question, can I use other NVIDIA GPUs or just the Tesla V100 you mentioned?
The answer is yes and no. As long as your GPU supporting the NVIDIA software development kits, then it's okay to run in the ALPS-GT. But the problem is you may not get as the same speed up as we get with Tesla V100. Most of the cars other than Tesla V100s, they're not targeting for the computer scientific computations.
Thank you. Another question. How many GPU cards should I use for simulations? Or how many can I use?
There's no upper limit, but for the rule of thumb, I think I always suggest you using around 4 cards for 2 reasons. One is that 4 cards give you enough computation powers from the cards, and also the most important thing is 4 cards give you enough memory on GPU that will not be the issue for the simulation jobs.
Okay, one more question. Does Empyrean provide the hardware solution, or do we need to find it by ourselves?
So there's a couple solutions for your questions. So if you have already have your a routine IT provider, you can ask them to providing your upgrade or server to adding those GPU cards, or you can come to us. We have partners that work on the pre-configured systems that was available to providing all those configs you need. And also the last solution is you can using the cloud providers like AWS or Azure. They can providing a GPU-based instance that you can running on.
Okay, another question, can I use AMD GPUs?
The answer is no, for 2 reasons. The first thing is we did check AMD GPUs before we developed the ALPS-GT, but the problem is the best computation GPU provided by AMD is like 10% or 20% slower than best of NVIDIA's graphics card. But the most important thing is AMD doesn't have something like a CUDA provided by NVIDIA, which is very free for developers to develop their own softwares to working on it.
Okay, another question. How is the ALPS-GT integrated into a Mentor and Cadence tool chain?
ALPS-GT, like also as ALPS, can be easily integrated into the mainstream design environments. You just click a few buttons, then the engine simulator will be swapped from your original simulators to our own simulators, and then everything else stay the same.
How in the simulation has it integrated in Virtuoso, ADE, XL?
Yes, it has the capabilities. Just click a few buttons, and then the engine will be swapped to ALPS-GT.
Please describe the hardware configuration.
So for the hardware configuration wise, we have the minimum requirement that requiring 4 of NVIDIA Tesla V100 GPU cards, and everything else like a CPU and memory, we can use using just the typical configuration of your servers. Let's say we can have 16 cores or like 128 gigabyte of memories in your system.
What about the Verilog simulator? Is it interpreted or compiled?
We have our own internal Verilog simulator, which is almost like for the simple, very easy Verilog simulators, and it is compiled.
Okay, next question. What are the ADC, DAC, SNDR, or effective NR of bits? Do you understand that one?
Yes,
Okay.
this is a very good question. It shows how accuracy your device simulator is. But unfortunately, I cannot tell you the exact numbers. But what I can tell you is the accuracy has been verified by the designer, and our result matches both Boolean result and their silicon results.
Okay, typing in your questions. We're scrolling through them. Next question, what is the data format, SST2 or PSFXL?
So just like other SPI simulator in the markets, we're supporting like FSDB, TR0, or PSF as the waveform outputs.
What kind of platform does this ALPS-GT run?
So because ALPS-GT is using NVIDIA Tesla V100 and using the CUDA toolkits, and that has a minimum requirement for like say CentOS or Linux 7 or Ubuntu 16 or Ubuntu 18. That was limited by NVIDIA's CUDA toolkits.
Okay, I think we have time for one more question. Is there any way to evaluate ALPS-GT without buying GPU servers?
Yes, because it's going to be very expensive to pay upfront, like say to buy a GPU-based server and just for evaluation. That's why you can also think of an alternative solution, which is you can use in either some cloud service like Amazon AWS or Microsoft Azure. They're providing some GPU-based instance where you can running set up easily and set up your environment for ALPS evaluations.
Okay, that ends the webinar. Thank you for attending and have a good day.